Number one, in this question, you will use graph theory and transition matrices to solve problems about a manager visiting 5 factories. Audrey is the quality control manager for a manufacturing company that has 5 factories A, B, C, D, and E. She is planning a route to visit each factory once, starting and finishing from her home age, starting and finishing. C determines the distance between each location in kilometers as shown in this table. Audrey wants to find an upper and lower bound for the shortest total distance traveled on her route, starting at H. Use the nearest neighbor algorithm to find an upper bound, right? So H nearest to A, 40, and A nearest to 50, to E, 50. After that, E nearest to 1, 60, to D, and D to C, 90, and then C to B, 80, and then B return to H, 85. So the upper bound, if you calculate 40 plus 50 plus 60 plus 90 plus 80 plus 85 equal 405 kilometers. This is A. Next question. To find a lower bound, or the uses the dilated vertex algorithm and delayed vertex H. Use Prim's algorithm starting at A to find the weight of minimum spanning tree for A, B, C, D, and E. You should clearly state the order in which the H are selected by the algorithm. Okay, part one. So we are going to use Prim's algorithm to find a minimum spanning tree, or MST. MST is minimum spanning tree. First, the first step, the edge with the minimum weight from E is E to A, E to A is 50 kilometers, okay, and the tree includes E and A, the edge with the minimum weight connecting to a new vertex is AD, 60 kilometers. And after that, the tree, the tree includes E, A, and D. So the edge with the minimum weight connecting a new vertex is DC, and DC is 90 kilometers. And the next step, the tree includes E, A, D, and C. So the edge with the minimum weight connecting a new vertex is DC. Is CB, I mean the CB equal 80 kilometers. So the total, if you calculate this, is 280 kilometers. So the total weight of MST is this one, 280 kilometers. Part 2. Hence, find a lower bound. This part 1. Part 2. To reconnect H to MST, H to minimum spanning tree, to MST, we need to we need to add two edges that connect H to the tree. From the table, if you evaluate the table, the two smallest distance from H, two smallest distance from H, from H, I mean, are HA is 40 kilometers and HE 70 kilometers. So the total distance from the lower bound, uh, is MST weight plus HA plus HE 280 plus 40 plus 70, and this is 390 kilometers. Next question. How? C. Sorry. After her initial visit to all factories, Audrey now decides she will visit one factory each day. She decides which factory to visit according to the following transition matrix. So this is the transition matrix. After visiting factory D, 3, there is probability of 0.4 that Audrey will visit factory C next. Write down the value of AB for PQR. Right. First, we need, if we find first P, okay, so the total probability is 1, so it means on this row, we can calculate that P equal 1 minus 0.2 plus 0.2 plus 0.2. This was 0.2, 0.2, 0.2, and equal 1 minus 0.6 equals 0.4. With the same strategy, you can determine as well Q. Okay, so equal Q equal 1 minus 0.7 equals 0.3. And after that, R, this is 0.4. So R equal 1 minus 0.2 plus 0.4 plus 0.2 equals 1 minus 0.8. It is 0.2. So this is 0.2, this is 0.3, and this is 0.4. On the first visit, factory A, write down the initial state matrix S0. So D part 1, S0, or the initial matrix is 1, 0, 0, 0, 0. This one. Next question. Find the probability that the fifth factor that Audrey visits is C. Find the probability that the fifth factor that Audrey visits is the same as the second factory she visits. Okay. Part 2. We need to find the probability that Audrey at C, at factory C, after 4 transition, or we are going to find T transition matrix, T transition matrix power 4 times S0 state matrix, right? So of course we need to find T power 4 first, and I'm going to start with T times T. T times T is T squared. T times T. This is A, B, C, D, E. I will concern only on row C elements. Row C elements is 0, also 0 0.2, 0 0.2, 0 0.4, 0 0.2. Okay, and multiply by t times t, 0, 0, 0, 0 0.7, 0 0.3, 0 0.3, 0, 0 0.2, 0 0.25, 0 0.25, 0 0.1, 0 0.2, 0 0.2, 0 0.3, 0 0.2, 0, 0 0.2, 0 0.4, 0 0.2, 0 0.2, 0 0.1, 0 0.4, 0 0.2, 0, 0.3. Okay, and next calculate the third rows, the C rows with this is T, matrix T, and this matrix T as well. So if we calculate, we got 0, 0 0.3, 0.26, 0 0.34, 0 0.19, and 0 0.24, 0 0.24, 0 0.18. So I could see here 0 0.14, 0 0.23. I will concern only on row C. This is A, B, C, D, E. And after that, this is T squared. And the next step is T squared multiply T squared. It is T power 4. Okay. And then I will concern to row C. Row C are 0, 0 0.34, 19, 0 0.24, 4, 0 0.18. This is T squared, row C of T squared multiplied by T squared. Okay, and 0 0.03, 0 0.26, 0 0.34, 0 0.14, 0 0.23. So just concern on the first column. Okay, and if you calculate, the result is, I will concern only the row C. Row C, 0 0.2162. That is 0. That is T power 4. So T power 4, T power 4 times the state matrix for the first row, second row, and this is C, D, and E. Okay. After that, multiply by 1, 0, 0, 0, 0. And the result is 0.2162 plus 0 plus 0, 0 plus 0, 0.2162. For the conclusion, we can state that the probability that the fifth factory of the visits is 0.2162. This is the probability. And next, part 3. Part 3, for D to D, the probability, the probability, the probability that this probability that the second factory is D, the probability is 0.7. So we need to find 0.7 times T cubed as 0 or state matrix. We need to find the value of this. Right, so it means I'm going to find first T cube. T cube times the state matrix. Okay. And I will concern only on D because D to D, it means on row D. A, B, C, D, E. Row A 0.03 on, this is 0.26 on, 0.34 on, this is 0.14, 0.32, 0.24, 0.21, 0.23. This is 0.23, so on. And then multiply, because D to D, it means this is D and this is row D and this is column D. So A, B, C, D. This is T squared, this one T squared. And this is matrix T squared, this is matrix T. This is 0, 0.2, 0.4, 0.2, 0.2. So this is matrix T, this one, T squared times T, and then times state matrix, the state matrix on D, so 1, row D. If we calculate, it becomes 0 plus 0.064, 0.096, 0.042 plus 0.046. This is T squared times T times 1. This the state matrix. And if you calculate the result is 0.248. But we're going to calculate 0.7. If 0.7 times T cubed as the state matrix, it means times 0. So the result is 0.1736. Next, for E to E, it means the probability, probability that the second factory is E equals 0.3. So we need to find 0.3 T cube as 0 or state matrix. Okay, this is E to E. Now I would like to find T squared, T cube as 0, but row E, so this is 0.03, 0.26, 0.34, 0.14, 0.23, 0.255, 0.24, 0.23, 0.26, so on. Okay, that. So this is T squared, and this is T, but column E, A, B, C, D, E. Column column E, 0.1, 0.1, 0.4, 0.2, 0, 0.3, and multiply by state matrix 1 equals E to E. Okay, so if you calculate, the result is 3,102 plus 0.048, 0.078 times 1, and because this one, state matrix, and the result is 0.251. So if 0.3 times 3 cube state matrix, it means times 0.3. And the result is 0.0753. So the probability that the fifth factory is the same as the second factory equal 0.1736 plus 0.0753 equals 0.2498. Next question. Over a long period of time, find the proportion of Audrey's visits that are to factory A. Find the expected distance Audrey travels in a day, given that she always travels directly from home to a factory and then back home. Okay, E part 1. We need to find the steady state factor because this question is about long-term behavior of a Markov chain. using transition matrix T. And based on the Markov chain rule, that T times pi equal pi. This is based on the Markov chain. And then sum the element of pi must be equal 1, or pi A plus pi B plus pi C plus pi D plus pi E equal 1. And then through this rule, we can writing the transition matrix 0, 0.1, 0.1, 0, 0.1, and then 0, 0, 0.2, 0.2, 0.4, 0, 0.2, 0.2, 0.4, 0.2, 0.7, 0.25, 0.3, 0.2, 0, 0.3, 0.25, 0.2, 0.2, 0.3. Okay, and multiply by A, by B, by C, by D, by E. So this is transition matrix, and this is matrix pi equal matrix pi based on this rule. By A, by B, by C, by D, by E. Now, we are going to simplify. Let A equal pi A, B equal pi B, C equal pi C, D equal pi D, E equal pi E. This for make easier for the identification. Okay, based on this information, we can writing around 6 equation: A plus B plus C plus D plus E equal 1. The second equation is 0.1. If you multiply this matrix, transition matrix, and this matrix, 0.1A 0.1b, I mean, because this is 0, 0 times 1 equals 0. Now 0.1 times pi b, or times b, equals 0.1b, 0.1c plus 0.1e equal a, or we can simplify, becomes a minus 0.1b minus 0.1c minus 0.1e equals 0. The second one, 0.2c, 0.2d, 0.4e equal b, or we can rearrange, becomes b minus 0.2c minus 0.2d minus 0.4e equals 0. And so now this one, third, I would like to start from here, more long, going to C, 0.4D, 0.2D, 0.2D, okay, and because this is 0, okay, 0.2B, 0.2C, 0.4D, and correct, 0.2E equal C, right? And it is 0.2B, 0.8C, because C minus 0.2 minus 0.4D minus 0.2E equals 0. Roll down first. Next, D, this part, 0.7A, 0.25B, 0.3C, 0.2D equal D. We can arrange, becomes minus 0.7A minus 0.25B minus 0.3C plus 0.8D equals 0. Now this one, last row, 0.3A, 0.25B, 0.2C, 0.2D, 0.3E equal E, and we can arrange, becomes minus 0.3A minus 0.25B minus 0.2C minus 0.2D plus 0.7E equals 0. Now, this equations we can arrange becomes a matrix. Okay, 1, 1, 1, 1, 1, and I'm going to separate 1, and then this is 1 minus 0.1 minus 0.1, 0 minus 0.1, 0. After that, 0, 1 minus 0.2 minus 0.2 minus 0.4, 0. And this is 0 minus 0.2, 0.8 minus 0.4 minus 0.2, 0. 1 minus 0.7 minus 0.25 is minus 0.3, 0.8, 0, 0. This is minus 0.3 minus 0.25 minus 0.2 minus 0.2, 0.7, 0. Okay, on the next step, you can use your calculator to find A, B, C, D, and E. So you have to set to your calculator to matrix mode and find A, B, C, D, E. Or you can use Gaussian elimination method or Gauss-Jordan method. Or you can use the eliminations and substitution method to find A, B, C, D. I have calculated, and through calculator, I got that A equal 23 over 221. In decimal is 0.10407 on, round off becomes 0.104. B, 42 over 221, or 0.19004, round off becomes 0.19. C, or pi C, equal 50 over 221, 0.226, on, round off 0.226. Pi D, or D, 52 over 221, 0.23529, on, round off 0.235. And pi E, or E, equal 54 over 221, 0.24434, so on, or 0.244. So the conclusion, we can writing that the proportion of other visits that are to factory A is this one. I would like to writing the proportion of Audrey's visits that are to factory A equal 0.104. So next, part 2. Part 2, I would like to writing the steady state matrix. The steady state matrix 0. This is A, or pi A, 0.104, and then 0.19, 0.226, 0.235, and 0.244. This is the steady state matrix. And the next, the expected distance, we can calculate through one, you can see on rows 8, 2 times 40, 85, 160. See, why 2? Because one round trip, it means 2. Go and return. And after that, multiply by the steady state matrix. 1, 0, 4, the steady state matrix. And if you calculate, the result is like this. Wait. 80, because 2 times 40, 80, times 23. This is 23 over 221, this number. So 23 over 221 plus 170, because 2 times 85 times 42 over 221. And after that, 2 times 160, 320 times 50 over 221. Next, 200 times 52 over 221. 140 times 54 over 221. And if you calculate, the result is 194.298. Simplify or round off becomes 194 kilometers. Number 2. In this question, you will first consider a statistical model for the number of fish caught in the lake, and then consider a differential equation to model the growth of fish in the lake. Althea enjoys fishing in a lake near her home. She usually fishes for 4 hours each day, and she records the length to each fish before releasing it back in the lake. Althea decided to perform a chi-squared goodness of fit test at the 5% significance level to determine whether the number of fish caught can be modeled by a Poisson distribution. She uses her records from the last 50 days to produce this table. Calculate the mean number of fish caught per day. So if this is X and this is F, so I would like to find F times X, 0, 7, 24, 33, 40, 40. And the sigma of F is 50, sorry, 50, not 40, 50. Sigma of Fx is 144. So now we are going to find mu or mean. Mean or mu equal 144 divided by 50 equal 2.88. So this is mu or mean. The next question, B. Hence, calculate the expected number of days in a 50-day period that Althea will catch no fishing according to the Poisson model. Althea calculates the expected, oh, this is the next question. Okay. B. Now, we want to find the expected number of days with 0 fish or without 0. So the expectation is probability x equals 0 times 50. This is the expected number. So the probability based on a Poisson distribution, x equals 0, equal e power minus mu times mu power 0 over 0 factorial. 0 factorial, fixed to 0 factorial is 1. This is also 1. So it means e power minus 2.88. And if you calculate, the result is 0.0561346. So the expected days it was 0.056134 so on times 50, and the result is 2.8067. Round off, 2.81 days. The next question, C. Althea calculates the expected frequencies and records them in this table. Explain why Althea has combined the columns 4, 0, and 1. So I have provided my answer about this. This is answer for part C. Next question, D. For this T-squared goodness of fit test, write down a suitable null hypothesis, write down the number of degrees of freedom, df, this one. This is AIHL null hypothesis. Find the p-value, write down the conclusion justifying your answer. D part 1. The null hypothesis is data can be modeled by a Poisson distribution. Okay, one. And part 2. To calculate degrees of freedom, we are going to calculate the procedure that df equal number of categories is 5 minus 1 minus number of estimated parameters. Number of parameters 1. It means the degree of freedom equal 3. Now we compare the observed frequencies and expected frequencies, and then we are going to create a table. Okay. This is the group greater than 1, 1 greater than this data, 2, 3, and then I have to scroll down first, 4, and then greater than 5. Next, observe, or O. It is 2 plus 7, 2 plus 7, so 9. This is 12, 11, 10, and this is 8. You can see this number on the both table. It's expected 10.9, 11.6, 11.2, 8.05, 8.25. And we're going to calculate observed minus expected squared over expected. If you calculate 9 and it is 10.9, the result is 0.331. For this row, is 0.014. For this row, the result 0.004. And if you calculate this row, it's 0.470, and this one is 0.008. All right, now t squared, the t squared, 0.331, 0.14, 0.004, 0.470, 0.008. It equals 0.827. Now use a t-squared distribution table or calculator. Okay, with t-squared, this one, and then the df, degree of freedom equal 3, 1. So it means the p-value based on this number, this one, and this one, p-value we can determine 0.843. 3. You can determine through calculator or through chi-squared distribution table. 4. Now compare the p-value with the significance level 0.05. 0.05. Okay. Between p-value and significance level. So that 0.843 greater than 0.05. So it means p-value greater than significant level. So insufficient evidence to reject H0 or to reject null hypothesis. Or we can state that we fail to reject the null hypothesis. So the conclusion we can state that data can be modeled by a Poisson distribution. Next question. A factory is built on the edge of the lake, and Althea is concerned about the impact of pollution of the length of the fish. Based on her records before the factory was built, the length of the fish could be modeled by a normal distribution with mean 50 centimeters. After the factory is built, the Althea collects a random sample, 15 fish, and calculates that the mean 48.6 and the sample standard deviation is 2.56 centimeters. Althea decides to test if there is sufficient evidence of a decrease in the population's mean length. The hypotheses for her test are null hypothesis mu equal 50 and the alternative hypothesis mu less than 50. Perform the test at the 5% significance level, so alpha equal 5% or 0.05, to show that there is evidence of a decrease in the population's mean length. Okay. E. The sample size, or N, given 15. The sample mean equal 48.6 centimeters. And then the standard deviation S 2.56 centimeters. And then alpha or significance level 0.05. Right. And the null hypothesis is mu equal 50 centimeters. Right. And then the alternative hypothesis, mu less than 50 centimeters is 50. Okay. Now we use the test statistic, t-test statistic, I mean, find mean minus mu over S over square root N. So this is 48.6 minus 50 over 2.56 over square root 15. If you calculate, the result is minus 2.118. Next, we are doing a one-tailed t-test with the F, degree of freedom, equal n minus 1. It means 15 minus 1, 14. Is degree of freedom. And significance level, 1, 0.05. From t-distribution table, or you can use in calculator, you can find or you can determine the critical value, equal, based on this information, degree of freedom 14, and then alpha 0.05. So the critical value is on minus 1.761. So we are in the region, in the rejection region. Alternatively, we are going to this, we are in rejection region. Okay. For the alternatively, we are going to calculate p-value using t-distribution table or calculator. So p-value equal p of t less than minus 2.118. On calculator or table, I got 0.026. This. Since p-value less than alpha, so since p-value, it means p-value, this one, less than alpha or less than significance levels, it means 0.026 less than 0.05. So we have to state that sufficient evidence to reject null hypothesis. So the conclusion, there is evidence of a decrease in the population mean. Next question. F, but this, okay. Althea now decides to consider the length of an individual fish in the lake as it grows. She researches the fawn, but talent-free growth model is stated that this one. So this is according to the fawn, the talent-free growth model. Where is one? This information. Justifying your answer, state whether K is positive, negative, or could be either. Okay. State the value of the LDT as T approach to infinity. Okay. 3 letters. F part 1. F part 1, DL dt equal K times L infinity minus L. This is a classic first order differential equation. And we use this on biology to model how organisms grow older uh, how the organism grow over the time. I mean, so this is the first order differential equation. L infinity is the maximum possible length, and then when the fish is young, when the fish is young, I will write it here. When the fish young, L less than L infinity. Okay, so we can state that L infinity minus L zero, this initial L is greater than zero. Next, for the LDT, for the LDT to be positive, so, or we can state the L dt greater than zero, the implication K should be positive also. So the answer of this question is K. K must be positive because it governs growth as well as it governs growth, and A is positive. So this one, yeah. So this the statement for F1. Now F part 2. As sorry, I have to scroll down first. Okay, as t approach to infinity, the fish approach for the maximum size or for the maximum number. So it means we can writing also that L approach to L infinity. So we can writing here that L minus L infinity approach to zero, the implication that dl dt goes to k times 0 and it's equal 0. So the answer for this question is as t approach to infinity. So the implication the L, the t approach to 0. So the fish stops growing. The fish stops growing once it reaches its maximum length. What? Next. The next question is F. F, wait, F part 3, sorry. State a parameter in the model that could have been affected by the factory pollutions in the lake. F part 3. We here. Let's consider what each parameter represents. Okay. So L, this is current length of fish. And then L infinity is the maximum attainable length, and then T is time. As well, K for growth rate, right? So the implications of pollutions, as we know that there are two implications for pollution. That first, wait, I will write it better. Write here. Implication of pollutions. Pollution. And the first, stand, the stunted growth. Okay. So stunted growth meaning fish cannot grow becomes big. So it's because the lower of L infinity, and the second is slower growth. So why? Because of the poor health of the fish. That means the lower K here we are going to writing. Now the answer for this question is the parameter likely affected by pollutions is L. The answer is uh, the parameter likely affected by pollutions is L infinity, since the length decrease. Since the length decrease, the parameter likely affected. Scroll down first. Okay. The parameter likely affected by pollution. This one. Next question. G. Sketch a graph of the LDT against T. You should label the coordinates of any axis-intercepts and the equations of any asymptotes on your sketch. Okay. So we plotting the LDT against T. Okay, the LDT. So there are two axes, the LDT axis and then T axis. At T equals 0, when T equals 0, this is the initial length. So it means the L, the T, the LDT, if the LDT is 0, it's going to be K times L infinity minus L 0. Okay. And after that, it means the coordinate point, this one, T, comma, this one. So the coordinate point is 0, comma, K, L infinity minus L 0. This is the coordinate point. Next, when t equal when t not equal approach to infinity, so LT will be approach to L infinity. So the implication, the L dt approach to 0 also. So the graph approaches to zero, the LDT. So it means if approaches to zero, it means from the positive goes to zero. So there is horizontal asymptote based on this information, and the horizontal asymptote occurs on y equal zero. Let's continue. Y equal zero, it means if like this dl dt, and this is t, so this decrease because this is the LDT equals zero or around here. Next, so the LDT starts at positive, okay, the LDT, and then decrease toward zero. So positive, so it means positive here, the LDT positive, and toward zero. Yeah, this is the LDT zero around here. So if we will sketch like this. The LDT positive, and this is T around here, positive, and towards zero becomes asymptote. Asymptote, it means uh, it never have, it never has the coordinate point, the intersection with T axis. It never has, only asymptote. Next question. Solve the differential equation the LDT equal k times L infinity minus L. Using the initial condition, we write your answer in the form L equal ft, L equal function in t. Right. H. The differential equation dl dt equal k L infinity minus L. Okay. This is the differential equation with the initial condition L0, the initial condition L0 equal L0 like this. This is the initial condition. Now, I would like to arrange this differential equation becomes the L over L infinity minus L equal K dt, this. Now, and the next step, integrate left-hand side and right-hand side. And after that, we're going to find the integral of left-hand side and right-hand side. It's going to be minus ln L infinity minus L equal kt plus c. And the negative move here, I'm going to writing the right-hand side minus kt plus c. Okay, so, and the next, if learn, it means based on the learn rule, we can writing that L infinity minus L equal e power minus kt plus c, or it is e power minus kt times e power c, like this. And if a equal e power c, we can writing it becomes a times e power minus k t, like that. So L infinity minus L equal a times e power minus k t. And then L, if L the subject, L equal L infinity minus a times e power minus k t. Okay, next, when t equals 0, L equal L 0, like this. So it means this L becomes L0. This means L infinity minus a power. This is become 0. So e power 0, like this. So it's going to be L0 equal L infinity minus a. So a equal L infinity minus L0. And recall that based on this information, that L equal L infinity minus a e power minus k t. This is L in t function. Okay. So we can state that from this information, can state that LT equal this one L. Sorry, this one. If this LT equal L infinity minus A is this one, this part, L infinity minus L0 times e power minus kt. This the answer.